Hello everyone, and thank you for joining today's webinar. Over the next hour, Richard Walker, FUTEK's Director of Engineering, and myself will be discussing the ins and outs of the LSB200 Miniature S-Beam Junior Load Cell, and we'll give you guys a short overview of the mechanics of a load cell and how it comes together. But first, I wanted to share a brief background on FUTEK and our expertise in the test and measurement field. So I want to start today's webinar discussing some general details about our company. FUTEK was founded in 1988. Actually, our founder has been working in the test and measurement industry since the 1970s. So we come with quite a bit of experience. Our headquarters are based out of Irvine, California, where all of our load cells are designed and manufactured. We are ISO 9001-2008 certified and have an ISO 1725 A2LA accredited laboratory. Besides our expertise in load cells, the company offers torque and multi-axis sensors along with electronic instruments. But today's focus will mainly be around our LSB200, which is of course part of our load cell series. FUTEK currently offers over 100 solutions within the load cell family, and as you'll learn, these products are very versatile in how they can be used, which is great for us because we get to see so many unique test and measurement applications. Now, FUTEK currently caters to multiple industries such as medical, automotive, and process manufacturing, just to name a few on there, but there's really a lot of industries that we are exposed to. I know that today's audience includes engineers that may have had some experience working with load cells, but for those of you who are new to this field, I'm going to give quickly a cover of the basics of load cells and how they work, and let Richard dive into the technical aspects of the LSB200 S-Beam Junior. We'll also spend a good portion of today's webinar going over the industrial examples, which I think you guys will find very insightful. Now, the main technology and component that we utilize in our load cells is a bonded foil strain gauge. There's other technologies such as piezo or semiconductor, but FUTEK's load cells predominantly use bonded foil strain gauges. In this slide, you can see a sample of what a strain gauge looks like. This strain gauge design is very typical, but the shape, functionality, and size can vary depending on the sensor requirements. The strain gauge shown is sensitive in one direction, and it's made of special alloy foils, which include Constantin and carbon material. The basic insulator backing is a polyamide or cast epoxies. Certainly there's other ones out there, but these are the two most common types. Now, we find that the strain gauge does offer great advantages, mostly in how robust it is. It's easy to use, and more importantly, you can utilize it on different forms and surfaces. This is very useful when you're dealing with non-flat surfaces such as tubing. We discussed the strain gauge and how it's a key component in the design of a load cell. But I want to spend a quick minute to discuss the form and functionality here, because I think it's really important for you guys to understand. So here you see two different load cell families being shown. Of course, there's various types of load cells out there. I'm just showing you two to get this point across very quickly. On the left-hand side, you see threaded rod end type load cells. These threads can be male or female, and these sensors are used then for inline loading conditions. On the right-hand side, this is what we call a canister type load cell. These types of load cells can handle a large capacity range in relation to its size. I also want to note how small some of these sensors can be, and ultimately that allows the engineers flexibility when there is any type of space challenge. Of course, each load cell has its own function and strength, and as we showed in the previous slides, those load cells were great for high capacity requirements. In fact, the highest capacity class in those models that I just showed could go up to 1 million pounds of force. Now, there's all types of measurements that engineers are interested in. These load cells are, of course, integrated in various systems, so we need to account for multiple scenarios, such as high precision, where accuracy is critical, or low profile, when we don't have a lot of room to install the load cell. There's also off-center loading, when the load cell or when the load is not being applied inline, and then there is endurance applications with the engineers performing cycle life testing. So we can often classify the application within these 5 categories and then determine what type of load cell is best suited for that type of environment. We talked a little bit about the function of these load cells, but I wanted to leave you guys with one last explanation. In this slide, we have illustrated an S-beam type load cell. These load cells are used in an inline loading environment, and they can measure both compression forces or tension forces as shown on the right. Although it may sound unglamorous, it's fair to compare a load sensor to a common spring. Well, a very stiff but repeatable spring. As is the case with the spring go, a load sensor will deflect either in compression or in tension where it elongates when a force is applied to it. If it's a well-engineered load sensor, it will deflect the same every single time given that same force, which introduces the idea of repeatability. And that's important, in the overall measurement of a transducer as well when we look at performance. Now, the obvious functional difference between a common spring and a load sensor is that the deflection of a load sensor is converted into an electrical output that can be measured. At this time, I'd like to pass the floor over to Richard Walker, who will be lending you his 15 years of experience. Remember, if you have a question pertaining to the miniature S-beam load cells, please feel free to submit it, and we'll try to answer them all at the end. Thank you.
Thank you, Naveed. And yes, please feel free to submit whatever questions you may have about this material or the applications we'll cover. I also wanted to thank you all for joining today's session. We know you're very busy individuals, but we're excited to share our knowledge across the engineering community. Now, miniaturization is nothing new to the market segment, especially today when you start hearing all about these micro machining and really small components and semiconductor parts. Now, the S-beam, it's a very common product, very large package size. You can see the example here, the big LSB302. What we've done is we've miniaturized this thing down. It's called LSB200. We've nicknamed this the junior because really it's the junior size compared to this much larger LSB302. What we found is we miniaturized this product. We ran into several challenges, from machining tolerances to how we were going to manufacture it, how the operators were going to complete the assembly, solder in the small cavities, cable attachments. So it was definitely a challenge that we knew that we had to overcome. Now, this beautiful junior S-beam LSB200 product, it was a new solution. We knew it was going to do well in the market that wanted miniaturized products. Now here you can see the LSB200 shown in three small different views: a side view, front view, and an ISO view. Now this product, it's a proven product. It's been manufactured for just over 10 years, and we've been able to have significant volumes that we've put through our production process. So we know that it's going to meet your requirements and your demands. It's been extremely successful across multiple industries, and we'll be covering those here shortly. Now, the previous slide, we showed you the main three pictures, but you really couldn't get a feel for the size of this product. Now you can. We have a golf ball that's they're right about 1.6 inches. And look at this junior LSB200 S-beam. The height is only 0.75 inches. Very thin profile, 0.26 inches. And the length, it's only about 0.7. Now, the beautiful thing about this product is the specifications. The nonlinearity, 0.1% of rated output. Great specification, meet a lot of industries that require the high accuracy. Can handle a lot of variations in operating temperature range. Now, what we're showing here is the standard operating range of -60 to 200 F. We have produced products outside of that. It becomes a slightly custom product, but we can go outside that standard operating range. And the output, it ranges from 0.5 millivolt per volt to 2 millivolt per volt. It is your lower level output, so you'll have to go into some electronics, and we'll discuss that here in the future. Materials, these are aerospace grade materials. This isn't the common aluminums. This is high quality aluminum and extremely high quality stainless steel that these parts are manufactured from. And these products, they have a very low deflection, only about 3 to 5 thousandths of an inch. Now, there are two main thread options that are available with this LSB200 products. It's offered in the English number 440 and the universal metric of M3 by 0.5. Now, this metric was really designed and developed to support our international customers or even our domestic customers that require metric solutions. Now, we can also manufacture custom threads if necessary, if they will fit on the part. Now, with this, you'll see numerous capacities. The beautiful thing is this product, it's the same mounting configurations, whether you buy a 10 gram, a 100 gram, a 5 pound, or a 100 pound force unit. It's all the same. So engineers, You may, if you accidentally select the wrong capacity, well, guess what? You don't have to retool. All you have to do is order the correct size and fit it right into the spot. You'll see here just some comparisons. We have a 10 gram shown on the left. It's about the weight of a pencil. Then you have flour, sugar, which is right around 10 pounds. And the tires, 5 normal tires. These aren't monster truck tires. They're going to weigh more than 100 pounds. But regular car tires, 5 of them is about 100 pounds. Just kind of gives you a comparison what this little tiny product can measure. Now with those capacities we just talked about, overload protection, especially for a product this small, and when you're talking about some of the lower capacities, 10 grams, 20 grams, 50 grams, it is extremely important to have overload protection. This product, you'll see the picture, the little cuts ends. This has an integrated overload stop that can handle up to 1,000% of full scale. We have taken product, specifically a 10 gram load cell. We've loaded 100 pounds on it in tension and compression, and this thing worked fine. There was no deviations from the sensitivity. It worked the way it was supposed to. Now we're going to take a quick break. We're going to show you a quick 1 minute clip, or approximately 1 minute, from our quality director, Tom Bowles. He's really going to discuss the approach the FUTEK has for the quality system.
We've recently initiated a product improvement initiative for the LSB200 family. We've involved everyone across the organization, from management through down to the operators who are performing on the production line, because they're really working hands-on daily with the product, and they've made some really significant improvements in the area. We've continually worked on the reliability of the product as well, and the product is so reliable we're able to offer a lifetime warranty against manufacturer's defects on the entire line of LSB200 products.
As Tom just got done mentioning, we offer the LSB200 with a lifetime warranty, and I think that really emphasizes the quality approach we here at FUTEK take. We're serious about this and our manufacturing processes. Now from our LSB200, we've spun off a couple other products that we found that the customers, they wanted a product that was similar to the LSB200, but they needed the features that would support their requirements. First one is the LSB200. Customers wanted this small package size, but they wanted it submersible. So we've designed stuff where people wanted to measure from a few inches underwater up to 100 feet. We're looking at going even further than that. Also on the other side is customers wanted this product, but they wanted an OEM version. They wanted something that they can mount inside of their own housings or requirements. So what we did is we stripped off all the things that they really didn't need. So we're able to make an OEM product that met whatever their budgets, their constraints, or their sizes. Now with FUTEK's in-depth background of a lot of different custom sensors, we've been able to leverage that experience we've gained and applied it to this LSB200 product also. Really, size variations when the customer needed something a little bit lower profile or a little bit taller, they wanted to fit in their applications, we're able to support that. Some of the non-magnetic for MRIs or other industries where they couldn't have ferrous materials. Also driving into vacuum compatibility, we've had numerous look at these type of products for the chambers where, again, they couldn't have outgassing or they had to have minimal outgassing of the materials. Radiation environments, this goes anywhere from a doctor's office to where there was extreme radiation in any nuclear facilities. Submersible, we just briefly touched on that on the LSB210, but this also could be in different medias, whether it's saline solution or ocean environments, or just, again, a media that's not water or common materials that we know that the product could be put into. For example, the acids and what kind of acids that this could be protected against. So now we get into the real, I'd say the meat, the fun part is the applications. Now a lot of these applications we had to generalize their concepts. We weren't able to really talk about the in-depth part of it, but we wanted to give you the audience a good overview of the capabilities. So again, please note, that the LSB200 is extremely versatile. This is only a few of the applications we're showing you. It's really where you as the engineer, technician, or innovator, you get to be creative and use this product really wherever you want to have a force measurement. We see the LSB200 used in numerous industrial automation applications, but there's three main ones we're gonna spend a little bit of time focusing on today, and that's the fiber tension, a little bit on the automated dispensing, and conveyor or check weighing assemblies. Now our first application up here is our fiber tension, and from here you can see the pictures. There's some rollers up top and going through this machine and this assembly. On the right, you'll actually see different directions the LSB200 product can be used in. You'll see the blue strings are taking the S-beam and pulling it up in a tension direction, and the red strings are pulling down, pushing down the S-beam in a compression direction. Now, ultimately, what this LSB200 product is doing is it's measuring the fiber tension. Why is that important? By not having the correct fiber in some of these manufacturing processes, the fiber could break. It means downtime of the machine. It means there's going to be an issue. Now, this is just one example of a standard fiber tension, real thin fibers. Now, you could take this LSB product and you can put it in line with other stuff. Thin paper, pulp mills, anything that you want to measure fiber or any type of a tension force on the products. The beautiful thing about the LSB200 is how thin it is. Now you could take a lot of these and you can put them extremely close together. Now we separated them just as a better visual representation for you, but you could put these things real close. Remember, this S-beam is only about 1/4 of an inch wide, so you can definitely take advantage of the area. Now you'll see that what's mounted on top of the junior S-beam is a bearing pulley type system that allows the fiber to go over on top of the sensor. And you want to make sure that you reduce the amount of friction, or reduce as much friction as possible that's being submitted over the S-beam, because you could potentially be producing any off-axis moments which would give you some erroneous data. Now for our second application, we see this has a conveyor belt with blue media or blue material flowing down that and dropping off into what we call a multi-head weigher. Now on this, you can actually measure it in a few different places. One being in line with the conveyor belt. If you had a conveyor going into a flat section, you can ultimately do some automated dispensing weighing right in line. But our main focus on this picture is really that multi-head weigher. It's where this blue media will be dispensed into multiple heads, and each one of those you can have a measurement. So do you need to know, do you have the correct media, the correct weight, flow rate, whatever it may be, you could take this LSB200 product and utilize it in that assembly. So now let's drive a little bit deeper in this multi-head weigher. And again, you can see the goldish box that we have highlighted, and you'll see on the sides of that, you'll see two junior S-beam LSB200 products mounted on the side. Now, you don't have to mount it exactly like this. This is just one example. You may want to have 3 load cells. It's really dependent on your application. Our application engineers can support you on some of the basic designs. But you may have 3 sensors, 1 sensor, really dependent on how big your platform is. But I hope you get a good understanding that if you mount the S-beam underneath your platform, you'll be able to weigh, again, that media or whatever you're trying to achieve. Now here we have some completely different applications. We talked a little bit about industrial. This is more focused on our test stands. This could be used broadly on numerous different test stands, and 5 of the main ones we'll talk about is linear testing. Is there any direct inline testing inside a frame? These are used a lot in spring testing because how small they are for some of the smaller design springs, and you'll see that the deflection is minimal. We previously said about 0.003 of an inch. Any type of verification testing, again, in your test stand, do you need to verify your product or validate it? Hydraulic compression testing, do you have a hydraulic where you need some type of force feedback mechanisms? Any small weight impact testing where you're doing some drop testing, whether you're trying to determine dynamic forces or force impacts. On the next slide, we'll actually show you one of those linear test stands. So as we were mentioning on the linear test stand, let's break it down a little bit. You'll see on the left-hand side, you have some type of linear actuator with this, what type of motor drive and whatnot. You got to design and come up with this. Just, again, more of a concept to get you thinking of the way that this product could be utilized. You have a stationary platform with some linear bearings or slides. The red, you have a movable plate. And this one, you're just showing some different parameters in there, cooling coils, heating bars. One thing to note, definitely you want to try keeping this product as consistent in temperature as possible. For this application, they were just using some cooling coils because it was going to transfer a significant amount of heat into the sensor, which we wanted to stay away from. But the main focus here is you'll see the S-beam is mounted in a way that it will be pushing against whatever its media or reacting against the media, and it will give you your feedback that you need, and that will give you the capabilities to give you your measurements. Now, these measurements that we'll discuss a little bit later can be tied into numerous instruments and really support you in achieving the results you need. Now, on the completely other end of the spectrum of test stands, we have our medical market, and the medical markets really utilize this product, again, because it's miniaturized. We have an OEM version that supports them mounting it inside the configurations. And again, it could be used on a lot of different products, but we're going to really focus again on four areas, and we'll show you some example of those here in the future. We have first one is it was used for DNA or cultural sequencing. It can be used substantially in IV or any type of bag weighing or bag dispensing, used in dialysis machines, and also in biometric testing, where physical therapy is going to be occurring, and they really need to monitor the person or the specimen that they're providing this therapy for. So let's drive now into this DNA sequencing that we briefly had a quick overview. And you'll see on the right-hand side, you'll see the red lines coming into this main pump structure. And what that is, that's the fluid coming in. And you'll see the S-beam products down below. And what that's doing is that's ultimately measuring the media that's coming in through those pump systems where the reds are. And then you'll have multicolor for exit lines where that material is coming back out. So ultimately the load cells were used for maintaining a consistency in that media as it was being transferred in and out of the system. So one final note on these type of designs is this product, again, is very small, and it can be mounted and configured in a lot of these processes or requirements that the customer needs. In this application, we have bag weighing. On the left-hand side, you'll see this has 4 bags. Now it could be a single bag, it could be IV bag. But on the right-hand side is what I really want to focus on, where you have the LSB200, where it's actually mounted. So this is top mounted from the top with some type of assembly and a tension hook with the bag weighing on that. So this could be utilized for measuring just the material in the bag. Is it close to being full? Is it half empty? It also can be utilized to help you determine flow rates by how much the volume or how much the weight of the material is changing. So then you know, again, how much flow rate that you have in this product. Now I want to step outside of just the medical market, is that not only is this used for IV, you could use this for any type of bag weighing. Are you putting fine powders? Or do you have a process where you have powders dropping into a bag or any type of small little hopper? So this is just one small example, again, that this product can be utilized in any type of weighing or hanging weighing application. Now we just spent a lot of time discussing numerous applications, and like I previously have mentioned to you, is wherever the engineer, technician, designer, innovator really can use this product, it can be created. But a few more areas that we've seen this used substantially in is in aerospace. They've taken this product and used it for center of gravity determination of small components. Used in a lot of robotics. Again, robotics is starting to become miniaturized, so this product can fit in there nicely. It gives you the overload capabilities, because sometimes a robot will slightly have a glitch in its closed loop feedback. So the nice thing about the overload stops, it will help protect your sensor. Used a lot in the automotive testing, even the product's so thin that it could be put next to each other to measure the windshield wiper, the amount of forces across the total windshield wiper. It could be used across behavioral testing, where they want to measure or monitor the behavior of rats or fish, crabs, crustaceans, whatever it may be. It's really endless where this product can be utilized, and that's the beautiful thing about it is it's so small, it's so compact, it has overload stops built into it. It's just a product that can be used universally. Just be creative with it and call our applications, and we can definitely support you on getting this product to fit into your application. You heard me talk in numerous of the previous slides about how the LSB200, and it's really important not just the product, but really mating this to the proper instrumentation. And you'll see the LSB200, it can go to numerous different modules or electronics, and for the main ones that you'll see out there is a handheld. I want to make this to a handheld because I want to be able to go around and utilize this not in a constrained environment. A panel mount because you're going to mount this in your assembly or manufacturing process. If you have DAC systems that need a voltage or a current input, an amplifier module, or some of the latest and greatest technology that's come out is the USB, where you could take this and plug it right into your computer and have some software, and you're up and running doing your monitoring or your data logging or what you need. And we'll be touching over the USB module here in just a moment. As I mentioned, the LSB200 married to a display or amplifier. The amplifier display is just as important as the product, as the LSB200, because you got to be able to get this data out. So it's extremely important to know, what do you need out of the product? Do you need high resolution? Do you need 24-bit resolution? Are you looking for the ultimate accuracy where you're trying to measure the smallest possible values? You need a high bit resolution. Do you need high speed, 4,800 samples per second? Are you doing a lot of dynamic testing? It's very important that also that your bit rate be as high as possible. Sometimes you could be at high speeds, very low bit rate, and you're missing a lot of that valuable data. So again, it's extremely important. You'll see FUTEK has really focused 3 instruments specifically on this page to be able to support multifaceted applications. 24-bit resolution, capable of achieving 4,800 samples per second in 2 different environments. Also CSG 110, we can push this thing up even faster, 25 kilohertz. If you're doing some extreme dynamic testing, definitely that's a product that could support you achieve that. And again, amplifier, you can get that in voltage output, current output. Do you have issues where you need to have that current, that 4 to 20 milliamp output coming out to you? And the nice thing about FUTEK offering not only the load cell but also the instruments is we could perform a full calibration for you. We can marry the display and the load cell together, give you a certificate, a calibration, and you're going to be off and running. You don't have to worry about trying to set this thing up yourselves, trying to solder, do connections or whatever it is. You get the turnkey system with the certificate if you order it. Now we know how important the USBs have become to our lives these days. Everything connects to the computer. And the USB solution, that's almost taking a DAC system, putting it inside a little module, miniaturizing everything, and providing the capability of going from an LSB200 or load cell directly to a USB module, plugging it into your computer, utilizing a Sensit FUTEK software that can log up to 16 different of these load cell USB modules, so you could put them next to each other for your fiber tension, or if you're measuring any type of array, force measurements. You can data log, you can graph. So it's extremely important to pay attention to marrying the correct load cell with the correct instrumentation that's ultimately going to give you a successful test or environment that you're subjecting these parts into is again marrying the correct load cell with the correct instrumentation. Now focusing a little bit back just on the LSB200 product is is a versatility. As you'll see, 4 configurations that we'll see a significant amount in the applications, or when a customer calls our application or sales engineers. You'll see in the top left-hand corner, we can provide some male threaded stud assemblies. Again, to simplify it, if you can't use the current female threads on it, we can go to different thread adapters or configurations. The bottom left, some basic plates. So if you want to do any small weighing where you don't want the sensor confined or fully mounted, where you're just going to have a little cup or some type of powder or whatnot that you're going to be placing it on top. Your upper right, some hook assemblies used a lot in your bag weighing, or you have some type of tray that you're hanging off the load cell because it will give you a direct inline loading. Or the bottom right, it's kind of what was shown in that fiber tension. You have a bearing inside of a pulley system to be able to give you the capabilities to give you a compression or tension force due to some type of fiber or small rope or anything that you can run through that pulley system.
Richard, thank you very much for that insight. I think you dove into a lot of good material over there, but I see that we have quite a few questions. So why don't we go ahead and address some of these and see how many we can get through. And for our audience members, if we don't get a chance to answer your specific question, we'll do our best to follow up with you individually once the webinar concludes. It seems like we have a question out here. It says, does it have to be calibrated with the instruments? And I think what they're trying to get to here is, what are the calibration standards that FUTEK recommends when you buy a sensor and the instrumentation that goes with it? Can a customer not calibrate it and do it on their own?
Very, very good question. Absolutely. If the customer has the capabilities to calibrate it themselves and chooses to perform that task, they can do that. But we have found that because we're set up, we're ISO 17025, we're an accredited laboratory, we have the tools and equipment right here in-house, it's easier for us to perform that calibration for them. We set it up with the instrument in the engineering units, if it's a display, or we give them the voltage or even the millivolt per volt outputs, whatever they choose, whatever outputs they want. We perform that calibration with top grade equipment, we provide them a certificate, and it really gives them a sense of assurance that they're getting a product that's fully calibrated, and they don't have to worry about trying to do their own soldering or connections or calibrations in their own lab, if they even have a lab.
Okay, that seems like a lot of good information for the audience to know. But a follow-up to this, a lot of times customers will ask us, how often should I calibrate it? I've been using it for 2 years or 1 year or even 5 years. Is there a recommendation FUTEK has about the standards of calibration?
That's a tricky question, mainly from the standpoint is our standard recommendation for an NIST traceable calibration is 1 year. That's something that we set up. But it's really up to the customer. How critical is that application that they're doing? Should they be verifying every 3 months? Is this product used with a lot of high cycles with potential of abuse or overload, or was the sensor going to be handled in a way that it could be dropped? I think you want the sense of assurance that that part is meeting your requirements. One thing that we do here at FUTEK is we have interim checks of our reference equipment. We don't wait for the 1 year calibration. We'll take every 3 months at a maximum and go through and make sure that that product is performing the way it should. You could take that advice also on your side. Have some basic weight where, if you can, check it. Make sure it's still within those parameters. It's still getting the results you want. Because the worst thing you're going to have is after 1 year, if you send it back for calibration and it's outside of your requirements or whatever your interval was. It just creates a lot of headache and extra work for you if you find out, again, that something happened to your sensor between your calibration intervals.
So as a final note then, they should always be testing their system once they get it, and throughout intermediate times, perhaps every few months, to just make sure everything is working the way it's supposed to.
Absolutely. I think if they have some type of verification interval, and again, it's dependent on how critical their project really is. Is it so critical that they can't be more than 0.1% out? Do they have some extra room where the sensor is really, for the accuracy, is over-designed for the product? Do they have larger room? So So the customer should really look at that part of it, and they can make that determination. And over the years, as they use this product, and if they do their own verification or calibration, they'll be able to really determine what their true interval is.
Excellent, excellent. Thank you so much, Richard, and thank you to our audience member who asked that. Okay, Richard, looks like we have a question here. It's saying, how many times can you overload the sensor? And again, this is drawing back on the overload protection feature you were talking about. We mentioned that it goes up to 1,000%. But perhaps if I overload that, how does it all come together and work? And how many times can I do this?
The overload is really designed in case something happens. It's not designed that you're going to continuously go into that overload condition. It's definitely not recommended to continuously go into the overload condition, but we have designed it in such a way so there will be minimal impact. Now, this overload protection is in the direction of the load measurement, so that's going to be the direct inline load. You have to be extremely careful with extraneous load. So is there going to be moments applied, or you're going to twist the product? There's no overload protection in that. So you can damage the product. It won't be damaged directly in line, but if you twist that part, you can have some issues with the product.
Okay. So the customers need to be careful during the installation as well, because it is a sensitive part. We are talking about a miniature sensor.
Oh, absolutely, and that brings up a great point. It's always recommended, or FUTEK recommends, have that sensor connected to your instrument while you're installing it. It will talk back to you. It will say, ouch, if you do something you're not supposed to do that product. Say you're going to over torque it. So yeah, definitely have the sensor connected while you're putting it into your system.
Excellent. Thank you for that. Okay, Richard, I think we have a question here. It reads, we're interested in the OEM version of this model. What are the volumes that FUTEK requires for these types of applications?
The volumes are really going to be dependent on the budget constraints of the customer. If the customer is very price conscious, the volumes definitely need to be several thousand pieces. And again, that's dependent on where their price point or where their costing needs to be for their total system. So for this question, what I would recommend is get a hold of FUTEK's application engineering or one of the sales staff members, and they can really help you understand where you're going to be as far as volume related to the pricing standpoint.
Okay, excellent. Thank you, Richard, and thank you to our audience member again. Some great questions out there. Richard, we have a question here. What advice do you offer to calculate offload axis?
Now, FUTEK has numerous of our, what we call an extraneous load data sheets. Those can be found right on our website. So if you're on our main homepage, if you scroll down towards, I believe it's the bottom under Smart Tools, there's a section for extraneous loads. Now that will show all the models, and you can go click in those, and what it allows you to do is determine what your off-axis loads are. It will allow you your force in your three directions and your moments, and it will give you a coefficient. Right inside that actual folder, there's a how-to guide of how to utilize these tools. So I would recommend to go drive down into the Smart Tools extraneous loads, or even when you're drilling down into the actual product, you'll find a little section for the extraneous loads for each model, and that should give you enough information to be able to calculate, again, the capabilities that these products have to be able to meet, again, whatever your offload accesses are.
Is there also a way that you can suspect that offload accesses happened perhaps originally in the application when you installed it? Everything seemed to be perfect, but it happens within 6 months or a year. Is there a way that you can test something like that?
That can be extremely challenging. One of the ways that we see that there has been offload access or offload extraneous loads on a particular part is that the zero will change. The customer may have a direct inline load of a certain amount of force, but there's extraneous load that they weren't expecting in. A lot of times it will shift the zero because, again, it's applying maybe too much extraneous load to the part. The only true way to know if there's extraneous loads is you have to go to a unique product, which is called a multi-component product, to be able to measure all those different forces together.
Excellent question and answer right there from Richard Walker. Again, over 15 years of experience, and I think it shows, and how much depth we're getting here. I think the audience is also appreciating what some of the comments we're getting back. Richard, we have a question here. To what depth can the submersible load cell be used in? And they're referencing the LSB210 that you had talked about. We mentioned that it can be used in underwater. So how deep can they go?
From what we have seen and the base of what we tested to, it's right around 100 feet we know the product's been subjected to, which under normal water is roughly right around 50 psi of pressure. We believe it can go substantially further. That's things that I know our engineers are looking at, how to improve our testing capabilities to really determine what that maximum pressure value would be. And by knowing how much pressure we could subject on the LSB200, we can ultimately kind of determine the depth or how far we can go under the water.
Now, Richard, I have a follow-up to this. When we talk about submersible, there's obviously all kinds of medias. We have different assets. You were talking about sailing, but what if it's something a little bit more extreme? How can a customer or an audience member here know to what extent they can push the product?
And at times that becomes quite challenging because some of the materials that we use, we only have so much information on that we can get from our suppliers. And one of the common feedbacks that we hear from a lot of the suppliers is you ultimately have to test it to be able to make sure it can survive that environment. And sometimes, we have to push that also back on our customer is we get in some gray areas that ultimately we need that relationship built with the customer where they're going to be testing it for their application. Because unfortunately, it'd be great if we were all-knowing, but we only have, the knowledge that we've gained through experiences. Now, we can set up tests to perform the test for the customer at whatever costs or whatever is associated. We could perform those tests in-house. But again, sometimes pushing that back on the customer is if you're being innovative and creative, sometimes that boundary is pushed and you got to perform the actual tests with the product. Same thing what we do with some of the coatings and whatnot. We have to push those environments past even what our vendors give us for information.
So ultimately, it goes back to this ideal environment where they're the experts. We have a lot of information on sensor technology, but it's really a joint partnership where the audience or customers in there should test it in their labs because they truly are experts in what they do. But we can be a facilitating hand in getting them to see how it all comes together. Oh,
absolutely, absolutely. A lot of times our customers have a vast amount of knowledge of the chemicals they're using and, again, what type of materials can be used with those chemicals with limited reactions and whatnot, and having them either, again, test it or provide that information. Again, like you mentioned, that partnership or, coming together is really beneficial for especially extreme applications where you're pushing the limits, you're pushing beyond of what the standard product can do.
Excellent, thank you. Richard, I have a question here about the Sensit software that you mentioned quickly. I believe this goes back to the USB technology. They're asking how many sensors can they pair up to this software?
Right now the software will support up to 16 independent USBs plugged in, and a lot of that also will depend on the customer's machine, computer. Is it up to par for the requirements? Yeah, we can pair up right now 16 individual sensors. And one thing I didn't mention previously, the beautiful part about the USBs is this isn't a dedicated 16 channel DAC. These are individual USBs, so you could bring all your USBs, your LSB200s, or even a different sensor in for a testing environment. You can knock out that test, and then you could break them apart and go do whatever test. It could be used individually. So again, it's a beautiful part about that USB product, especially when you marry it again with the Sensit software. So I guess the quick answer is you can go up to 16 channels. I know I've heard, and I know the engineers are probably going to be upset at me here, is that I know they've been throwing around some ideas of going to higher channels, but that's still really at preliminary designs.
One of the other questions that came from an audience member was whether the USB kit or module, if it's built into the LSB or if it's, how does that all work?
The USB, it's an external module that the LSB200 comes off with its cable assembly and goes to the USB module. And then we see that predominantly either plugged directly into the computer or into some type of small USB hub, especially if you're going to have multiple of these USBs being plugged in. So it's not actually built into the LSB200. We would love to do that, just technology isn't there yet for us to be able to achieve that. It's an external module that's plugged in, like I said, either in the back of your computer. One thing just general everybody to know is the USB, if you have the module, you're going to be running a cable length. You really don't want to run more than 15, 17 feet without some type of repeater system, because that's its capabilities today.
I see. And what about environments when we dive deeper into this USB again? It seems like is it industrial? Is it something that our users should take with some caution? Is it more for laboratory, or what do you recommend?
We're seeing a lot more of the industrial systems utilize the USB technology. Originally, it was definitely designed for the lab environment, but again, the industrial applications, the computers are becoming that much better without not having dropouts of the USB system. So we're seeing a lot of PLC systems coming out with USB capabilities, and we're just going to continuously see that technology evolve. We're seeing USB 3.0 coming out. That's really going to ramp up speeds even further. So there's a big push in that technology for industrial applications.
Excellent. Thank you, Richard. Okay, it looks like we're running a little bit short on time here, so we're going to make this the last question. And it's a very straightforward one, but perhaps something that our audience with a little bit less understanding on the technical side can appreciate. We have an audience member asking, can you further explain millivolt per volt and what it means?
That's a good closing question. From the standpoint is especially on the sensor side, we take these things for granted. And what is millivolt per volt? Ultimately, what the standard load cell is, without any of the additional displays or amplifiers or electronics, the load cell itself will be able to provide a millivolt output. For example, if you're exciting the bridge, the Wheatstone bridge of this load cell with 10 volts, and you're getting a 20 millivolt signal out, which is a differential output, you're getting 20 millivolts per out. What you're creating is 20 millivolts divided by 10 volts excitation. You're generating a 2 millivolt per volt output. What that is that's ratiometric. Let's simplify it even further. You had 20 millivolts at 10 volt excitation. Now you excite it with 5 volts. Now you're only going to be getting 10 millivolts out. So 10 millivolts again divided by the 5 volt excitation, again you end up with 2 millivolts per volt. So ultimately what that is you're getting a millivolt per volt output, but that's a ratiometric between the actual output of the load cell and the excitation that's generated that you're inputting into the sensor.
Next, that was a lot of information to take in, but hopefully our audience caught on to all that. And again, if there's any additional questions, if we didn't get to your question, we will follow up with you individually. Unfortunately, that was the last question we had time for, and I'd like to take the time to thank you all for joining us today. And as Richard mentioned, we understand how busy you guys are and really appreciate you sitting in. And just as a token of our appreciation, one lucky attendee will receive an iPad 2. For more information on our LSB200, please visit our website, futek.com /LSB200. You'll find a lot of great information about the product, everything that we talked about today. It will basically be summarized for you, but I think with the insight that Richard gave us, we certainly have a lot more information and expertise now on this transducer. And as always, please feel free to contact us either through email or phone if you have any questions on your applications. You will be receiving an email from GlobalSpec with a link to the on-demand version of this presentation, a PDF of this PowerPoint, an FAQ document, and of course a Q&A transcript. Again, thank you for taking the time to sit in with us this afternoon. Take care, and we'll talk to you soon.
I would like to thank everybody that was able to attend this webinar and really take the time out of your day. I know everybody's extremely busy, especially these days of getting our work accomplished, and I hope that you learned a little bit about our technology, what the load cell is, and definitely about the LSB200 and how that may be able to simplify your life as far as doing any type of force measurement feedbacks. So again, we appreciate your time and thank you again.